Morning, guys. All right, we're going to start with just a warm-up of something that we covered in 6.1 to get ready for our follow-up day in 6.2, day 2. So find the area of the regions enclosed by the curves of y equals 7 minus 2x squared and y equals x squared plus 4. So the first thing that we have to do is graph both of these. Okay, so we're looking for that region that's enclosed. We could see it. We need to see those points of intersection, negative 1, 5, positive 1, 5. So all that we're really focusing on here is top minus bottom, red minus blue. So 7 minus 2x squared minus x squared plus 4 from negative 1 until 1. Right? Put that in here. And you get 4. Okay. So we're going to continue with this idea of having a base such as that, having a shaded region, and then from there, cross sections coming up out of there. Monday's lesson was always horizontal lines or parallel with the x-axis or perpendicular with y, and we might see a change to that today. So the first example for today. Find the volume of the solid with circular base of x squared plus y squared equals 25, so the picture's given, and the cross sections perpendicular to x-axis, which translates to parallel to y, which would be vertical, which would be y equals values. Okay? And these cross sections are rectangles with a height of 2. So in our graph, what we really want to sketch are just vertical slices. Right? There's an infinite amount of these vertical slices, and each one has a rectangle coming up out of there. So we draw that cross section. If we sliced this vertically and lay it flat on our page, I like to keep the slice and the dimension running in the same direction when I put it on my page. Right, so that vertical slice running from the top of the circle, we could call it, to the bottom of the circle, is still running in the same direction on my page. Okay. We know that the height is 2, and the distance on that green highlight is what we need to figure out. Okay. You always figure that out based on the equation that is given. X squared plus y squared equals 25. We manipulate that based on the direction of the slice. Since it's vertical and it's y equals, we need to take x squared plus y squared equals 25 and solve it for y. Okay, this is the part where the symmetry comes into play. Anytime you have a y equals or an x equals equation, that is the distance from, you could always use the origin, but you don't have to, but from the axis up or over to the corresponding coordinate. So because it's a y equals, it's up. Right, so for example, if x was 0 here, and the location that I just drew that line, then y would equal 25 minus 0, square root y would equal 5. But the rectangle isn't just representing this 5, it would also be the other side of that circle. So similar to yesterday when we solved with square roots, we needed a plus and minus. In order to get the complete distance, we have to multiply this by 2. So it's 2 square root 25 minus x squared. Okay, because of the symmetry. So if, a rule of thumb here, if your shape is bisected by an axis, right? So if it's a vertical slice and it crosses over the x-axis, unless we're dealing with circles, we're going to have to double it. The only reason we don't double it with a circle is because we only want the radius. And the opposite would be true too. If we had a horizontal slice and the graph was symmetrical over the y-axis, we might have to double it. Okay, so look out for that. Think about whether or not you have the complete distance of the dimension that you need. So in this case, we did not. We doubled it to get the entire base of that rectangle. All right, so now we have our cross-section. We have the dimensions of it. I think I have the next page laid out for us to continue. So we just need next to figure out what's the formula for the area of this cross-section. All right, well, the cross-section is just a rectangle, right? So base times height, length times width, however you choose to refer to it. So area of a rectangle equals length times width, or base times height. So either way, it's 2 square root of 25 minus x squared. That's your base. That's what's lying flat. That's the slice. And the height was 2. Okay. Might as well simplify this a little bit. When we put it into our integral, we would have a 4 square root 25 minus x squared, and it's a dx. Okay, so vertical slices, y equals means we have x's in our integral. In order to get our limits of integration, we need to get x values. Okay. So going back to the graph, we go on our x-axis and we find the furthest left number and the furthest right number, and that is -5 until 5, here to here. Okay, so go ahead and take that and put it into your calculator. What's up, Gav? If that's more comfortable, I don't care. Okay. Okay, so integral -5 to 5. We don't need a parenthesis this time because we don't have any addition or subtraction. So 4 square root 25 minus x squared dx. 157.08. Units cubed. Okay, so we change the direction here. The base, it's not really a function, but the base equation was a circle, x squared plus y squared equals 25, and the cross section was a rectangle. Next one, graph given again. So the region bounded by the graph of 2x minus x squared, and the x-axis is the base of a solid. So it's in here. This is the base, this is the two-dimensional surface. For this solid, each cross-section perpendicular to x or parallel to y, which would be vertical, which would then be y equals numbers, right? Anything running vertically on a graph is a height or a y value. And we have triangles where the base and the height are the same. So coming up out of this graph, we have triangles Doesn't really matter whether they're right or not, but the height and the base are the same, okay? So when I draw my triangle, I'm drawing it as a right triangle just because that's more natural for me. But again, it doesn't really matter. What matters is the dimension is consistent with the direction that I drew it. That helps me keep my head straight that it's a y equals height and exactly where is it located. So from the x-axis up to the parabola. What's the volume of the solid? Okay, so let's figure out what these dimensions are going to be. So we have, the nice thing is they are the same. So once we figure out the green highlight, then we also know the height. So distance from x-axis to graph, up, y equals, that will be exactly what this equation is. We don't need to manipulate it in this case. Okay, the reason we don't have to, we don't have symmetry, we're not above and below the x-axis or right and left of the y-axis, we're not crossing over. Okay, so if you ever wanted to test, if you weren't too sure and you're like, well, you know, how do I know exactly what this one is, for example? Okay, well, based on my x-axis, I'm located at 1 right now. I could plug that in. 2 times 1 is 2 minus 1 squared. So I would have a height of 1. And that makes sense. This distance from x-axis to curve is 1. It's exactly what my equation gave me. Okay. So then over here is also 2x minus x squared. So the formula for the area of a cross-section, well, we have a triangle. So that's 1/2 base height. So we have 1/2 times 2x minus x squared times 2x minus x squared. We could write that as 1/2 quantity 2x minus x squared squared dx. Okay, go back to the graph because we need limits of integration and they need to be x values. All right, so we go on the x-axis, farthest left to farthest right value, 0 until 2. Okay, put this into the graphing calculator. We get 0.53. Units cubed. Okay, so in summary, if the cross-section is perpendicular to the x-axis, right, that always translates to me as parallel to the y, or vertical, then the integral representing volume will be in terms of x because it would be vertical and y equals, and we'll integrate over x values. If the cross-section is perpendicular to y, or parallel to x, or horizontal slices, that is x equals, then the integral representing volume will be in terms of y, and we will integrate over y values. So the direction of the slice of the cross-section is very, very important here. Okay. These are the textbook homework problems. we can go ahead and do them. Again, they're not homework, it's not necessary, but they're just a couple of extra examples. Okay, so let's take a look at them. X squared plus y squared equals 1. It's a circle again, just like the first example we did today. Desmos will graph this nicely for you. Graphing calculators, you would have to split it up into two equations and do the positive and the negative by solving for y equals. Radius is going to be 1 all the way around. And we have triangles, perpendicular to x, parallel to y, vertical, where the height and the base are the same. So if I slice and I get a triangle out of there, this and this are the same, anywhere along there. So that's a y equals equation, because it's vertical. So I take x squared plus y squared equals 1, and I solve for y. I have that symmetry going on, right? If I just did y equals, I would only get half of the triangle's base. So I do need to double the square root 1 minus x squared. The height and the base are the same, so this height is also 2 square root 1 minus x squared. Integral, area of a triangle is 1/2, 2 square root 1 minus x squared, squared, because they're the same. Dx, x values or x numbers are in there. I go from left to right, -1 until 1. Okay, that's the setup. The answer . .67. Okay. Last one for the day, x squared and 3. Cross sections perpendicular to y, which would be parallel to x. So Gavin, just go and draw your pictures first. Yeah, because then I can help you edit that, okay? Draw your pictures first. Okay, go back into Seesaw. Okay, so cross sections perpendicular to y, parallel to x, horizontal. So our slices are running this way again, and they are squares. So there and there would be the same dimension. There's that symmetry, right? Be careful. We crossed over the y-axis. The parabola is symmetrical left and right. So for horizontal, we do take our y equals x squared, solve it for x equals, and it is a square root of y. So that would be a plus or minus. So if you solve and you would need a plus or minus, that could be an indication that you need to double it. Right? Because root y would only give us one direction. We need both, so we have to double it. So area of a square is 2 root y times 2 root y, or 2 root y squared, dy. Y's are in there, so we have to go from bottom number to top number, 0 till that horizontal line of 3. Okay, answer is 18 here. All right, so that's it for today, guys. There'll be a third video on Friday. Next week is when you'll see the worksheet and the quiz appear. All right, take care.